You know, if you pick any day on the calendar, it probably seems, well, pretty ordinary. But the thing is, every single date is like a thread that connects amazing stories across centuries. And today, we're going to pull on one of those threads, February 26th, just to see where it takes us.
So, what makes a day significant? A famous battle? A big political treaty? Yeah, for sure. But what about a mathematical puzzle? Believe it or not, today we're going to uncover this surprising mathematical tapestry, and it's all woven into the fabric of this one single day.
And our journey, well, it spans nearly 400 years. It connects the death of a 17th century nobleman who loved to make puzzles to a modern physicist who is building bridges between nations after the Cold War. It's this vast, incredible story of different lives and ideas, all anchored by this one day.
All right, let's dive into our first chapter, Puzzles, Politics, and Peril. Here, we're going to meet two really remarkable Frenchmen. They were born centuries apart, but they are forever linked by February 26th.
Okay, first up, meet Claude Gaspar Bachet. He was a nobleman who died on this day way back in 1638, and his whole passion was creating mathematical puzzles. Then, on the other side, you've got François Arago, who was born on this day in 1786. He was a physicist, a swashbuckling adventurer, and even a revolutionary politician. I mean, two totally different lives, but they share this one date.
Now, Bachet wasn't just some hobbyist. His book from 1612 was foundational, just packed with stuff like card tricks and river crossing puzzles. He even posed that super famous weighing problem. Could you weigh any object from 1 to 40 pounds using the fewest possible weights? The answer, by the way, involves powers of 3. You only need 4 weights. Bachet basically turned math into a game, a recreation. And that's a legacy that's absolutely still with us today.
But here's the thing, math isn't always just fun and games. Sometimes it's a really high-stakes adventure. And for our second Frenchman, François Arago, it was literally a matter of life and death.
Arago's story is just wild. It sounds like something out of a movie. He was sent to Spain to measure the Earth's meridian right in the middle of the Napoleonic Wars, and he gets arrested as a spy. He manages this daring escape only to get captured by a warship. After he's released, a storm blows his next ship to North Africa, where, you guessed it, he gets captured again. And through all of that, he protected his scientific data and finally made it back to France as a hero.
And Aragon's story just goes to show you the incredible reach a mathematician can have. He didn't just stop at science. Nope. He went into politics, eventually becoming Minister of War and the Navy. And he used that powerful position to push for one of the most important human rights reforms of his era, the abolition of slavery in all French territories. You see, Arago's whole life was about applying logic and reason to the world around him, not just in science, but in policy and ethics too. This focus on rational thinking leads us right into our next chapter, the power of probability, and how one of his intellectual interests ended up having this massive global impact.
Arago had some incredible foresight. I mean, he saw that this calculus of probabilities wasn't just some abstract thing for academics. He argued it could regulate insurance premiums, create mortality tables, and, as he put it, be the influence under which lotteries and other shameful snares have definitely disappeared. He saw it as a tool for progress and for social justice.
Okay, so now let's jump forward in time, way forward, more than a century. On the very same day, February 26th, but in 1985, 2 more mathematicians passed away. And, as it turns out, both of them had dedicated their entire careers to the very field Arago had championed all those years ago.
One of them was Albert Bharucha-Reid, who worked with something called stochastic processes. Now that sounds super complicated, but simply put, it's the math you use to model systems that have some randomness to them. Things like the stock market, the path of a tiny particle, or even how a disease spreads.
And Bharucha-Reid's own story is just remarkable. As a pioneering African-American mathematician, he published over 70 papers in 7 books, becoming a major figure in probability theory. But what's truly incredible? He accomplished all of this without ever actually completing a formal PhD. I mean, that's just a testament to his sheer brilliance and dedication.
So on that exact same day, Tjalling Koopmans also passed away. And if Bharucha-Reid was advancing the pure theory, well, Koopmans was the one who showed the world just how powerful those ideas could be in practice.
And here's the payoff. In 1975, Tjalling Koopmans was awarded the Nobel Prize in economics. And what for? For his work on the theory of optimum allocation of resources.
He was using mathematics and probability to figure out the most efficient way to use limited stuff, like raw materials or labor. It's a fundamental question in economics, and his work helped crack it.
So all of this brings us to our final theme, building mathematical worlds. Because, as it turns out, mathematicians don't just solve problems, they also create the communities and institutions that make those big discoveries possible in the first place.
Yeah, for several other people connected to February 26th, their greatest contribution wasn't a single theorem or a specific formula. It was actually building the structures and connections that allowed mathematics to grow and thrive across borders and across generations.
I mean, you can think of these people as the architects of the global mathematical community. You have Karl Geiser from Switzerland, who put together the very first International Congress of Mathematicians, starting a tradition of global teamwork that's still going strong. Then there's Victor Neumann-Lara, who built a world-class research school in Mexico practically from scratch, putting the country on the international map. And Ludwig Faddeev, who died on this day in 2017, founded an institute in Russia specifically to bridge the gap between scientists after the Cold War.
Okay, so let's bring all these different threads together and see the full picture. Let's look at this single day's mosaic and what it really reveals about the true nature of mathematics.
So what does this one day's history, this whole collection of puzzles and perils and incredible breakthroughs, what does it really tell us about the world of mathematics?
Well, it reveals this absolutely stunning mosaic. It shows us that mathematics is timeless, connecting Bachet's 17th century parlor games all the way to the modern physics of Faddeev. That it's global, spanning continents from Arago's France to Neumann-Lara's Mexico. That it's profoundly human, driven by stories of adventure, of perseverance like Bharucha-Reid, and a passion for building community. And finally, that it is everywhere, shaping our games, our Nobel Prize-winning economics, and even our struggles for justice. These hidden stories are everywhere, even in the most ordinary places. So the next time you just glance at a calendar, maybe take an extra second to wonder, what kind of hidden history does that day hold for you?